All right. Good morning, everyone. Let's get started with today's class. So I do not have new content for you, but I do want to talk a little bit about the project, your grades, and then I'll give you some time to work if you want to take that time to work on your projects. So I guess perhaps if we start with grades, Aminder, did you, just to double check, did you have a time to post the extra credit replacements? Okay. So just to share with everyone, so Aminder has been working really hard at grading everyone's quizzes and assignments and all that. And so one of the things that I don't know if you understood from his email, but the way that we are doing the extra credit assignments is if you did an extra credit assignment and you got a better grade in one of the extra credits as you did compared to the grades you got on the mandatory assignments, then your extra assignment grade is replacing the grade of your lower graded mandatory assignments. Let's say if you did all extra credit assignments and you got 100% on everything, you're not going to see a change in your grade, right? So the extra credit is just going to help you if you got a better grade on any given extra assignment and you got a lower grade on one of the mandatory. They're just replacing that grade. Does anyone have any questions about that? Okay, so Arminder did ask you all to double check your grades to make sure that things are matching. Again, we're all humans, we can make mistakes, and so it's possible that something that we could have made a mistake when grading. So if you think there is a mistake, we're always open to connect with you and understand from your perspective. And if there was indeed an error from our side, we're always happy to fix it. But if you don't look it, if you don't find it, then we're not going to be able to know, right, if we made a mistake or not. Of course, we try not to make mistakes, but still, in case we do, we're always happy to fix it. So take a look at your grades that you have now. If something is not making sense, let us know and we can talk about it. All right, so I guess for those of you doing the design, the experimental design final project, I will give you some time if you want to ask something specific later, just because each one of you has a different data set, so it could be a very specific question. So I'll give you some time later, but before we go there, I do want to talk with those doing the machine learning side, which you're all working on at least the same starting data sets. Perhaps your final data sets are different depending what you do with your data, but the starting point is the same. So if you've been working on the machine learning project, if you have gotten to the point of training models, you may have seen that this data and the models that you're training, including XGBoost, is taking a long time to train, right? So I heard that from different students, and I just want to share some of the things that I heard, and if anyone else then wants to share what you found on your side, we can also, that would be awesome as well to do. So one thing is this data, the one complicating component of this machine learning data is that it has a hybrid column that has just a lot of different hybrids. And that is one of the things that make this data very complex to train, perhaps, is just because you have a lot of hybrids. In this case, corn hybrids. So I was talking with some students, and one of the ways that so I know that some people were able to train an XGBoost and random forest model, but it took like over 24 hours nonstop running in a powerful computer. So if you're running that on a perhaps not as powerful computer, like if it's your laptop, it may not be that powerful. It may even take longer than that. So I'm saying that for a couple of reasons. One is, do make sure you start working on that, because as you're seeing, just training the model may take over 24 hours. So if you leave this to the next minute, you're most likely not going to be able to turn in on time. The second part of this is what are some strategies that you can do to decrease the runtime on your side? I do want to share some of that with you. So really, if you think about it, the point that is taking a lot of time is the training. And if you remember, the way you do the training is really, I mean, as long as you follow some overall guidelines, but the specifics of those steps is really up to you. Of course, if we had unlimited time and unlimited computing power, you'll like to do the training, the most complex training possible, because it would give you the better chance of truly finding the best model. However, if that is not the case, as probably is not going to be, you're not going to have unlimited computational power or even just very high computational power to do this, then we need to look into some trade-offs here. What can you compromise so you can still train these models? And even though it's still going to take some time, but maybe not like, I don't know, 2 days to run. So a few things you could adjust on your training strategy is one is the number of folds of your resampling. So in class, we were doing 10 and we did just fine with that. For this, 10 is going to take more time, obviously, than doing just 5, for example. So maybe if you want to start doing, using 5 folds, that's going to train just a little bit faster. And if you think about it on the training, so let's just use the example. I'm just going to launch NER Studio here just to give you some numbers here for you to kind of think about. So let's say you do 5 folds. So V equals 5. And then on your hyperparameter fine tuning, let's say that you do a total of 100 combinations of all those different hyperparameters. So a total of 100 combinations for hyperparameter values that you are evaluating. So what this means is that really when you're training, you're running 5 times 100, this would be 500 models, which is pretty small, really, if you think of it. Like we were doing, I think, 10 V, so we using class at V of 10, and I think we did the 100 combinations. So that was 1,000 models that were being run. Even though you're not seeing that, but behind the scenes, it is running all those many models, right? Because basically the number of combinations that you're evaluating on a given grid or just a search in general, and then the number of folds that you're applying that to. And you think, okay, I mean, even if you're doing 500 models, maybe that is not such a big deal. But then I got feedback from one student that it was taking about almost 2 minutes to run each model. So then if you start doing like 500 models times 2 minutes, this is going to be 1,000 minutes. And if we do, man, R is trying to interpret everything I'm saying here. Maybe I should have done a Quartal file instead. But if we just do, 1,000 divided by 60, this is 17 hours. Right, so it adds up very quickly. So this is just a word of caution for you that, maybe you're not going to really be able to impact much how much time each model takes to run, but you may be able to impact, and you can impact how many models are running, right? So you can play that with first how many combinations of hyperparameter values you're evaluating, and then how many folds you do on your resampling strategy. Those are the 2 ways you can play around with that. And then, well, let me close this here just to, I want to show you something in Quarto perhaps. One way that you can also have an idea of how long it would take to run one model. So even before you do the actual training, what you could do is do some benchmarking for how long it takes for one model. There are different ways of doing benchmarking. There's some packages you can use, but one way that's pretty simple and straightforward, especially if you're using Quarto or Markdown, that you have the chunks, you can play a chunk. There is this function called systime, perhaps. Yeah. So there's this function called systime, which if you run it, just gives you the current time on your computer. So let's say that you assign this to an object called start, and then you have here your code for training, or for not training, but for running one model with just a fixed number of hyperparameters. And then in the end of this chunk, you do an end and then systime as well. and then you just do n minus starts. So let's say if you run, so imagine here you're still gonna have code, right, that I don't have here. That would be the code to run one model with one combination of hyperparameter values. If you just go ahead and run this chunk, it's gonna start with the start. It's gonna take some time to run that one model, let's say 2 minutes. And then when it finishes running, it creates this end time object, and then you just do an n minus starts to get how much time it takes for that one model. This is a way that you can gauge on your computer how much it would take to run a single model. And maybe that gives you some idea of, if you have 10 folds and 100 combinations, then 1,000 different models, multiplying this by 1,000 gives you some idea of how long it will take on your computer to run all those models. So just some strategy here for you to be able to gauge how much you can do on your training based on how long it takes for a single model to run. All right, I guess first, any questions about these specific topics here on how long it takes to train your models?
Dr. Bastos.
Yes, Shakir.
Yeah, I'm sorry, I'm not in agriculture. So I think my data wrangling was not as efficient because I don't understand what to keep and what not to keep. So it took me over 8 hours to download the data from Daymat. And I have around 39 million rows. I tried to do a density plot to see the distribution. It gives me an error. It says that we cannot, like, the data cannot be processed because it's over 4 GB. So the CSV file that I downloaded, that's like around 8 GB. So
Okay, to tell you all the truth, I have not analyzed this data myself, so I don't know the struggles you're all going through. But at the same time, I think that's a good thing because it gives you the opportunity of going fresh into a data without guardrails from my side. But I guess that would be a great question for others. Has anyone working on the machine learning project seen that long to download DayMat data?
no.
No. Okay, I see everybody
Yeah,
nodding no at least. Yes, online.
yeah, I went through, but I don't know, maybe it's because I don't have like a very powerful computer. And also another issue I kind of ran into was pushing to GitHub. It's not going. It seems like there is a limit on the amount of um how heavy the file is. So I can commit, but it's not going to push to GitHub. So yesterday I ran into the problem and I had to like create a new branch to be able to like push all of my work again from the beginning because the other branch couldn't like push anything any longer. And also this morning, I was also able to like wrangle and merge all the file again, which took time. But now I'm also running into the same problem of pushing to GitHub.
So is that Comfort?
Yeah.
Okay, Comfort, that's a great point. And so let me tell you this. So can you share with us what is the file that's very large at this point, or what is the object that's really large?
It's the merged one, like of all the files, the weather data, the meta, the traits, and everything, including the hybrid. It's like a really large file.
Yeah, I'm having the same problem. So the downloaded file, the CSV file, is over 8 GB, and whenever I'm trying to pull it on the GitHub, it says that it's crossed the limit, which is 4 GB, uh,
Okay,
for storage in GitHub. So I'm very lost.
you're in the
I
room.
also was wondering if there is something we are supposed to like exclude from the data sets to make it less complex because it's like a lot of rows.
So one thing which is what I mentioned earlier, if you think of it, weather data applies to the site year level, not to the hybrid level, or not to. So imagine, I mean, I know Comfort, you have field trials. Shakir, maybe you wouldn't be able to really think about, I mean, from your area of expertise, but if we go on a field and we plant, I mean, we can have thousands of plots, but that is one location, 1 year. So all those 1,000 plots are still seeing the same weather, at least from the perspective of the weather data we can get, right? Like we get weather data within a 1 by 1 kilometer pixel size, meaning that most likely your entire study would be within the given weather data cell. So all of those observations are getting the same weather. So I guess at least from when you're pulling data from DayMat, you do want to make sure that you pull weather data for the site year and not for the plot level. You can
Yeah.
for the plot level, but it makes no sense because it's going to be all the same for the site year, right? So maybe that goes back more to Shakir's question of how long it was taking to pull from DayMat. I would assume you're probably pulling for all rows of the data set, which assuming you're pulling for each plot, which is not the goal. You should pull for each side here. At least from the pulling side, perhaps that's what's going on.
Dr. Bastos,
Mhm.
you're right on that because I initially tried pulling the weather data after I'd combined the files and it was like pulling from like the plot level. It was taking like long, so I kind of aborted. And when I talked to my team member, we decided to like pull from the sites here itself, and that was really fast. But then I didn't have issues with that. But now combining the three files, except if you think maybe we're not meant to combine the three files together, the weather data was fast to pull and download, and I even exported it like easily after like on nesting and everything. But combining the three files together was where the problem started again.
Okay, and when you're combining, I'm assuming you're using a left join
Yeah, I used the left join.
based on the site and year information.
Yeah, site here.
Okay, well, so let me ask others, at least, I mean, either online or here in Athens, when you were combining weather with soil and the agronomic data, were you having issues? Was it taking a lot of time? Okay, I see some heads nodding no. So maybe Comfort.
I've already been able to combine everything
Mhm.
like and run good, not a problem, but pushing to GitHub is, I think, the problem now
Okay, so let's talk about that.
because the file is large.
So a couple of things there. One is, so yeah, GitHub has a limit of how large a file can be for it to be able to push to GitHub. But before we talk about that, I just want to ask others that have done the wrangling and maybe if you have pushed already to GitHub, or maybe even before pushing, but for those that already got to that point, was your combined file very large, like 4 gigabytes or something? Megabytes, not gigabytes. Okay, so Comfort, I'm not sure exactly
Yeah.
why, but it seems like maybe something on your processing is multiplying rows to an exponential extent and
Okay.
is giving you that very large file. It shouldn't be that large. And that's what, I mean, I would not expect it to be that large, but again, I have not done myself, but I'm seeing some people that have gotten to that point saying that theirs is not that large. So what I would recommend is if you open a GitHub issue showing maybe the part of the code where you are doing the
Okay.
part, and maybe people can help you, and maybe I can also help you, but especially others that have done this already and have not run into that issue, maybe they can get some insights on the difference between what you're doing, what they're doing, and maybe finding the reason there. So I would
All
recommend
right.
that.
Yeah. Thank you.
Yeah, and then I saw that you also had a question about yield. So yield is in megagrams per hectare, just to confirm. So even though it's
Okay.
lowercase m, but I think that was because of clean names, but it
Okay.
would be megagrams or tons per hectare.
All right.
Yeah, and also on the topic of large files on GitHub specifically, yeah, GitHub has a limit to how large files can be for you to push. So if you end up creating very large files, which again, I think something is going on that we can avoid that. So I do not expect you to have to create very large files for this project, like over 4 gigabytes. But whenever you do, if that is the case, like whatever process you're doing, if you do end up creating very, very large files like that, that still should not be like, it shouldn't be your final file, I guess. Well, maybe it is depending on what you're doing. Well, anyways, what I'm trying to say is if it is an intermediary file that you are doing something, but then you keep processing and then it decreases in size after processing, you can just ignore that file from being tracked with Git. So there is a Git ignore file in our in all of our Git folders that you can add there a path to files you want to ignore, meaning that Git is not keeping track of that file, meaning that it's not going to be pushed to GitHub when you do push everything else. That would be an option, which what's going to happen is that specific very large file is just not going to be pushed to GitHub, so you're not going to have an issue there. Of course, that makes your project not fully reproducible. Like if I will download or clone your repo, I'm not going to have access to that data, but it's still, I would be able to at least to see your code and see what you're doing with it, right? Yeah, so I guess my recommendation specifically to Comfort is take a look or post on GitHub to see if other people that have done this and have not created large files can maybe help you and see what is the difference between theirs and your code to see maybe what you can do to avoid that. Because I would not expect for files to be like over 1 gigabyte, really. So maybe there's something going on your side that can be avoided and they can probably help you with that. But if in any case, if you're doing something different from others that is still valid and you still want to go that route, then I would just add that file to the git ignore file on your Git. We did not go through that in class, but it's a very simple process. If you just Google like how to add a file to git ignore, you can find a solution for that very easily.
Dr. Bestos,
Yes.
how do we incorporate the block? Like, so can we just take out the block column from the inter data set?
It's up to you. My recommendation is that only keep variables that make sense when you make a prediction.
Okay.
So when you make a prediction, are you going to have a block number? Think about that. That's where I leave it.
Thank you.
Yeah.
I do have a question. For those of us like who don't have access to a super powerful computer for 24 hours, what would you recommend?
Okay, so Charles is asking for those of us without access to a high powerful computer for a long time, what do I recommend? I would recommend first you do this code here to just figure out on your computer how long it takes for one model to run, and then you can adjust your expectations of how much time you can dedicate to this. You know, perhaps if you know how much time one model takes, you can adjust your number of folds, your number of hyperparameters that you're fine tuning, and gauge from there. And maybe you can leave your laptop running overnight. Maybe that would be enough. And if not, if it's just like nothing is working, maybe you're just going to be limited to how many hyperparameters you're fine tuning. You know, maybe you're going to have to choose 1 or 2 hyperparameters and just constrain a lot how many you're evaluating in the end.
So that means that you might not have the best model.
Right.
And the challenge is
Yeah, it's true. I have to acknowledge it, but at the same time, so one solution, if you're really, of course, so just a reminder, all of you doing the machine learning one, the challenge itself is a cherry on top, right? It's just for fun. It's not going to impact your grade. So even if your model is very poor, as long as you did everything correctly, that's right. So one thing that you could do that we all have access to, we just did not learn in class, is we do have access to the high computing processing. There's a whole acronym for this, but there's a high computing cluster here at UGA that we all have access to for free. Of course, you have to learn how to use it, which is not like quickly. It may take you some time, but you can submit a job there, give your data, give your code, and let it run on their servers.
yeah, I think that was my thought.
Yeah. Yeah, so that is a resource available to everyone at UGA. So if you are willing to learn how to do it and you can do there, I'm fine with it. So you do have access to it. It's just not, the simplest. You have to learn how to do it. But but it would be a resource if you really want to, if you're really fierce about getting that award in the end, and you want to make sure you run the best training possible, you do have access to the high cluster computing facility at UGA.
Yeah.
On these ones in the lab, you mean? Yeah. Yeah, I don't know how it works though with like, because I know sometimes these lab computers, like after midnight, they reset. I don't know. Yeah.
Because I tried running on these earlier for my course, and when you come in the morning and you are not able to find because your laptop has to be connected. And then if you run the code, then you get like the result. But the other method is if you run the code and then you can make a table
Mm-hmm.
and then so your result can be saved in the code, like in that table.
Mm-hmm.
So it helps.
Okay, so there are ways to get around this. And again, like if you're limited by computing power and you don't have the time to learn how to use the high performance cluster here at UGA, you can just fine tune one hyperparameter or whatever it is that works for you. I understand that. Like I don't expect you all to be able to fine tune all the potential 8 hyperparameters if you don't have access to a high processing computer. But yeah, you may not win the competition, but you're gonna still have potential of getting 100% of your grade. So which I think is probably the most important thing. All right, any other questions? All right, so that's all that I had to share about your grades and also the machine learning final project. So my goal for the remaining of today's class is to basically give you time to work on the final project. I mean, if you want to work on something else, it's up to you. You're all adult to do what you want. But if you do want to use this time in class to work on the final project, perhaps be able to talk with your partner. I'm gonna be here until the end of class. I'm just gonna be here. So if you have questions for us, we're gonna be around to help you out. So if you want to use this time for that support, you're welcome to do that. And then just before, well, I see you have a question, Omar. I'll be with you just in a sec. And just to let you all know, so we have one more in-person class meeting, which is going to be next Tuesday. We're going to have an opportunity. I do want to ask you all that if you can make it, please make it. We're going to have an opportunity for extra credit. And you have to be in class for that to work. So please come if you can. I also don't have anything planned for teaching you new content next Tuesday. So it's also going to be another opportunity for you to ask questions, work on your projects, and use this dedicated time to make progress on that. I know we're all busy with other courses and finals coming up, including ours. And so even if next class, if you have questions about the content, about, we can go through a little bit, spend a little bit of time talking about the final project. Although we have already done it, but we can just clarify some points if you have questions about that as well. So before I let you work on your final projects, Omar, I saw you had a question. Please go ahead.
Yes, Professor. I just remembered that you mentioned while introducing the final project that you will take into account the number of pushes to Git by each member. So I think it will be helpful for the whole class. Like each of us have different schedules. Somebody's taking more courses, somebody's taking less courses. So based on the timeline and everything, I'm just wondering, like, I don't know, like some might not be able to do that many pushes, but they might do everything together and then push it. So how are you gonna incorporate that
Okay.
complexity?
So a couple of thoughts here. One is I'm gonna check the pushes. I mean, not the number of pushes, but how much you worked, right? It's not like because you can type a letter, stage, commit, and push, and that's a push, but it didn't do anything,
Yeah.
right? So it's not the number of pushes necessarily, just how much work each one of you did. I do recommend that you commit often. So even just within your computer, do commit often, because if you go on a rabbit hole and you want to get out of it, if you committed your way into that rabbit hole, you can find your way out of that rabbit hole more easily if you have committed a lot. If you start today from zero and you just stage commit at the end, then it was useless pretty much, right? Using Git was useless because it didn't really keep track of your steps. So I would say commit often, even if you don't push, commit often on your side. And if you think of like working together, perhaps one way that people can work together for the machine learning part is maybe one person can work on one script that is dealing just with XGBoost. The other person can train the other model, right? As long as you're talking and you are agreeing with decisions, I'm okay with that. So you don't have to necessarily work on the same script, right? You can like split tasks and each person does one thing. Of course, for you to start training, you're going to have to start working on your data, pulling data, wrangling data, getting it ready to the point where you can train. So that part has to happen first. But after that happens, you can kind of like each person can run a different model. So that would be one way that, if one person doesn't have as much time now, but the other has, you wouldn't compromise the progress of the other person.
Got it. Thanks.
All right. I guess before I give you time to work on your final projects, anyone has any questions that you'd like to share at the group level? Mm-hmm. Yeah, so if it's an algorithm, so Micah here was asking if I recommend using paralleling your code in your training. So I have not used parallel with a lot of different models, but I know that some models are more prone to be used for parallel computing than others, right? So especially models, so if you think of, like, for example, random forest is a model that basically each tree is getting a different version of the data set that's completely independent from the other, right? So random forest is very easily parallelizable because each core gets a different tree, a different set of data. It's all independent, right? So it's easy to parallel. Some other models may not work like that. Some other models, maybe the second step depends on the first step and they're all connected, which may be a little bit more difficult to parallel. So what I'm trying to say is if you can use parallel processing, great. You're just gonna need to find the balance between whether or not the model you're training is parallelizable or not. Yeah.
Is there any drawback to trying it?
So the drawback of, so let's say if you try to parallelize a model that's not really parallelizable, maybe it's not going to even work to begin with. It's going to say like it's just using one core. And sometimes even, I'm just thinking here, like even in cases where I did parallel computing, if it was maybe a model that was not as complex or maybe a data that was not as long, sometimes you actually lose efficiency parallelizing because there is some overhead on the parallel process that it has to split things and then it has to combine in the end. And if your case is not really like you don't have this huge data with a very complex model, sometimes just that overhead is actually less efficient than just doing in one core. So that could be like, maybe like a con of using parallel if the situation you're working with is not really prone to benefit from parallelizing. But other than that, I think there's not like, there's nothing else that you would be missing or losing by parallelizing. Yeah, thanks, Micah. All right. Any other questions or thoughts before I let you all work on your projects? All right, I don't hear anything.
Dr. Basu,
Yes.
can you hear me?
Yes.
My last question, like, is there any way we can make our R run on our GPU? Like, if I have a good graphics, then is there any way I can run that? Like, I can make my R run entirely on the GPU, or I can split the like power between GPU and CPU.
Yeah, that is a good question, and I don't know the answer to it. yeah.
I actually do.
Okay,
So if you're talking about XGBoost specifically, unless you have a Linux system, the XGBoost infrastructure to run on the GPU is not really worked on and doesn't work in R.
okay,
So you have to have a Linux system to work, but
okay. That's great. So let me just share that. So that was Ashbin, right?
Yes, Professor.
Ashbin, so Shay here in Athens, he has experience with that. He was saying that if you're working on a Linux system,
Mhm.
perhaps it would be simpler for you to make use of your GPU instead of CPU for faster processing. But
Okay.
if you're on a PC system, the communication between R and making that change to GPU is not quite there, and so it would be maybe impossible, maybe just
it's not
very difficult,
very.
very difficult to make it work.
Yeah,
So
I tried to do that in Windows. Like it was really difficult to make a connection between these two.
yeah, so I don't have experience with that, but Shay here was sharing his thoughts, and I think your experience has been the same as what his sharing here. So
Thank you so much.
thanks for the question. Well, anyone else that has been working on the machine learning projects will like to share experiences, failures, successes, challenges with others. All right, I don't hear anything, but again, I do encourage you all to use GitHub and to communicate. You know, that is, I don't consider that cheating. I just consider that community, right? You're helping others to learn from your mistakes, perhaps helping others to not commit the same mistakes. And again, mistakes are part of the process, right? We learn through trial and error. Mistakes are just part of it. So I do anticipate you're all going to make a lot of mistakes, as I do when I'm running any new project. Of course, in class, I create things in a very logical and, format just so it's easier for you to learn. But in reality, data is not like that. Data is complex, and there's a lot of decisions you have to make, a lot of errors you have to make to get to the right one. So. All right, so with that, just to make sure you all understand, I still expect you to be in class, so I'm not dismissing you from class. I'm just saying that I'm gonna give you time to work on your projects, and if you can talk. This does not have to be a silent class. You can talk with your colleagues, share information, walk around. It's really, think of this as the fun part of the hackathon, where we're just in a room full of people doing the same thing, and you're just, enjoying yourselves and helping each other. So I'm going to mute myself here just so the conversation in Athens does not interfere with those online. But if anyone has any questions for me, the speaker is still up. So just call me and I'll come to my computer and I'll help if anyone has questions for me. All right, and I'm also going to stop recording because I think from this point on, it's just going to be us all working. But yeah, if you have questions, let me know and I'll come back here and we'll talk about it.